A very good afternoon to everyone. Today I welcome you to this session of mobile application development. In this session, we will learn about the execution environment. We will also discuss the journey of APK, right from the development environment to the device it is installed. Then we will study various components of Android application. We will also study the anatomy of the Android application and activity lifecycle. So, first is the outline of the PPT. So first is the execution environment, then journey of Android application from APK to target machine, then components of Android application, then anatomy of the Android application. So next is the life cycle of the Android activity. So first is Android Virtual Manager. So it is an emulator configuration which emulates the hardware or software or the profile of device which is to be emulated by the emulator. This thing we have seen in the practical part where Android virtual device was used to create the virtual devices with the system image, that is with the operating system, whichever is used for the testing, and the hardware profile. Suppose we want to have the RAM 4 GB or 6 GB, then we can emulate the hardware configuration also. So then new emulator will come into the play. So in AVD configuration, we have three ingredients. First is hardware profile, that is RAM and the screen size. Its resolution is also there. Then we have the system image, that is the operating system, which is to be used in the emulator. Then we have the emulator skin storage area, that is the skin which you see, how you differentiate between different emulators or the mobile phones, simulated mobile phones on your Android Studio. So, I want to explain this diagram. See the device, it says this is the AVD manager. This is emulator 1. This is emulator 2. This is emulator 3. Or you can say virtual device. I told you in the lab that how we can create the different virtual devices uh, in the system. Fine. So let's suppose this is a screen size of 5 inch. Emulator 2 has size of screen inch of 6 inches, and this is 6.5 inches. Fine. And once you have made these profiles, supposingly this is having API 30, this is having API 22, this is having API 21. So three different memories will be reserved by the AVD manager for three different devices. For example, you want to install the app on API 30, that is, you will say play button for it. Fine. So that means this is your API R, probably Red Velvet. Fine. So I want to deploy my app on Red Velvet version. So I'll press the play button. So what happens? My AVD manager will choose this device to run my application. If I choose same application to run on API 21, then I have to press the play button, which is for the device emulator 3. Let us name it as A, B, and C. If I want to play my application or deploy my application on A device, then we have to press the play button of this one. And if I want to uh, deploy the application of B device, then we will deploy the application on B. Similarly for C. Everybody, every device will have the play button inside the AVD manager where you will deploy your application on device A, B, and C respectively. Now, these three devices occupy three different spaces in the machine. So they are entirely separate. This machine will be in the different environment, this will be in the different space, and this will be in the different space. So all of them will be in the three different spaces where they will run individually. So we can choose any one out of them to deploy our app. So this is how this AVD manager is responsible for creating the isolation between these three devices as they are running in the individual form. So this is what is written in the text. An emulator is an application or a virtual device or a prototype which develops and tests the application without using the real device. So it is a simulated mimics the hardware, or it is a parrot or software feature of the device. So, but the only difference is that you cannot make a phone call from this device. Although it runs the full Android system stack down to the kernel level, and it also have the pre-installed applications like when you buy a new mobile phone. So it is just the mimic of your actual device with the hardware and software features. Even skin is also there. So each AVD, like I told you that these three AVDs which were on the board, they will work as an independent device. So they have their own storage and data. In each configuration, and Android platform is specified. That is, you will specify the APIs on which this emulator will work, along with the set of hardware and emulator skin option. Whenever we launch this emulator, we specify the AVD configuration that we want to load. As soon as we launch the emulator with an AVD configuration, it automatically loads the data and SD card data, that is your uh, like your phone has extended memory in your SD card. Similarly, we can have the SD card option in our Android Studio, and we can load the data from that SD card to our AVD directory. AVD directory will contain the data which is to be deployed on the AVDs. So next, this is very important. How debugging in Android Studio takes place. So these are the 5 points, or I must say 5 components, which helps you to debug the application. Debug is the process of finding the errors when we are not able to build the application or when we are not able to compile the application. So both Java compiler and Dalvik translator will provide the error information if they cannot build the application. See, there are two steps. See, there are two steps when your information can have the error. First, when you write the Java code, it is to be compiled using the Java compiler first, that is using the Java C, and here you find some errors. So that means Java compiler is refusing that there are errors in the code and I cannot build this. Second, once Java code has been converted to the bytecode, this bytecode is taken input by the DEX compiler, which will convert it into, which will run this bytecode into the Dalvik virtual machine and convert it into the DEX code. Fine. Just like JVM in in Android Studio, we have the DVM. In DVM, the output is as DEX code. So if my DVM refuses to convert this bytecode into DEX code, that would also be an error. And these error messages are stored in a terminal in the Android Studio where you can see the logcat option. Here many errors will come. That is the log of the errors which has been encountered. Log is basically the list of the list of the errors which has been encountered while compiling of the code by either Java or Dalvik virtual machine. Fine. So logcat is the terminal window where you see list of the errors in your Android Studio while either while compiling by Java or by DEX compiler. So next, Android debug bridge. Then Android provides a logging package called Logcat. It is a general purpose from which the developer can find out the error messages when the app is running. So this stores the messages when you run your app, and Logcat will have the list of errors. So Android debug bridge, it provides an interface to running device or an emulator. That is, whenever you press the play button of the Android device in your Android Studio, then Android debug starts communicating with the emulator. It is a command line debugging interface. See, when you will not get that screen into your Android Studio window or your emulator window, then it will ADB will raise an error, no emulator started, or emulator has an error. Then the most important component, Dalvik debug monitor service. This we will see in the diagram that how it will communicate, but it is for the debugging environment. and it is window based. Next is TraceView. TraceView is a utility which keeps the track of all the methods which were called by the application during the execution. Fine. There are a number of methods which you deploy in the Android Studio in your Java code. So TraceView is a utility which keeps the track of all the methods which were called during the while you were running the application. So next, the very important diagram. So this we will explain. See, first step, DDMS is Dalvik Debug Monitor Service. It starts while connecting to ADB. Whenever you start playing the virtual device, DDMS debugging monitor becomes active. It starts with the connection of ADB. Fine. Next, when a device connects the virtual machine, your ADB will connect to the VM and sorry, your emulator, and emulator is installed inside the VM. Then this service called virtual monitoring service becomes active. VMS becomes active. So it is written whenever a device connects the virtual machine, the monitoring service is created and it will monitor minute to minute activity which is going on in this system. It is used to monitor the minute to minute activity which is going on in this system. So it keeps the informed information about the starting and termination of the VM. See, when you deploy your app, the VM will be started. When you actually remove the app or you have some errors, you will correct those errors and reinstall it. That means this error, this the app will actually terminate. Suppose this is your virtual device. When you build, suppose this is your hammer and this is your play. When you play this, your application is deployed. Now your application is crashed while installing. That means it has encountered some error. Now it has to be redeployed after correction of error. Once you have corrected the errors, redeployments will say terminate this app because it will remove the previous version of APK from from your Android device and reinstall the new APK. Fine. So this will be terminated and new APK will come into this place and your device starts playing the new app which you have installed. So third point is clear. Now DDMS retrieves the VM process ID. See, VM emulator is running in this VM, so it is denoted by a process ID because the operating system has to differentiate which APK is running where. So for that, it has associated PID with each of the APK. Then it opens the connection to the VM debugger by the ADM daemon on the device. So this has to be elaborated little bit. I tell you how. I earlier told you that there are three VMs or three virtual devices: VD1, VD2, VD3. Okay. Suppose I want to test my app on API 21. This is API 29. This is API 30. This is API 30, which is R. This is Q, and so on. You can go and find which is 21. Now this is my ADB. Now when we press the play button on API 21 VD, that is virtual device 3. Then what happens? It will open the connection between this and VDI3. ADB will open the connection between itself and VDI3 so that it can see whether the app is deployed on VD3 or not. Suppose due to some problem, it is not able to install the app on VD3. Then ADB says app contains error. So there will be one message which will be raised by ADB that it contains error. So or cannot launch app. This is a message that is there. Cannot launch the app. That means it is not able to launch your app on the requested virtual device. So this is how DDMS works. Now DDMS can communicate to VM and everything can be monitored. If it is deployed, then it is okay. And if it is not deployed, then it will give you the message cannot launch the app. So next topic is also very, very important. That is journey of APK from development to deployment. Where APK is developed, it is developed in Android Studio. Now, what is Android Studio? It is an IDE, integrated development environment. That is, it is an environment where you can develop the Android applications. IDE to develop the Android applications. Or it is one-stop solution to development of Android app because it provides you XML, Java. Combining them, you can have also the connection with Firebase so that you can deploy your app on your AVD devices. You see how your app look like on the virtual devices, or you can imagine that they are the real phones where you can test, develop, and deploy your apps. So your resource files, these are of 4 types. One is layout. Layout is the design part where the files are developed in XML. Next is your string, any string you want to use, any colors you want to use, any maps or the icons which you want to use in your app are supposed to be in the map folder. Layout, then is your colors file, string, then map. These are the 4 resource folders which are there in your Android app. Next is your Java file. That is the coding part of the design part. So together they are packed into the APK. Together they are compiled and packed into the APK. APK stands for application package. Android application package. APK stands for Android application package. Now, this is how you develop. One in Android Studio, you will develop the Android app. So there are 2 types of resources. One is resource file, another is Java. Together they are compiled and made one single archive called .apk. Together they are compiled and clubbed together in a single archive that is called .apk. And its full form is Android APK or Android application package. Now what happens? This is packed into the archive called .apk. Now this APK is developed. First of all, in environment, it will be developed. Output of this environment is .apk, and it will be installed on any device. It will be installed on any device powered by Android. It will be installed on any device powered by Android. That means .apk can be taken to the any device which is having the Android operating system. This is how the Android is developed. Android app is developed, and then it is deployed onto the Android device. Now, what happens after installing the APK? After APK is developed, now comes the picture part. First of all, your app store is there, which is into your phone. Suppose this is your Android device. App Store, Google App Store is there in every Android device, or iOS App Store is there. You have installed one application, APK1, APK2, APK3. I told you that Android kernel is powered by Linux. It's a Linux based system. So Linux is a multi-user system. If you can read out on the right hand side, first point is Linux is a multi-user system, and each app is considered as a separate user. Every app is considered as a separate user onto your phone. If there are 20 apps, that means 20 users are there. User 1, user 2, and user 3. Fine. Next, each installed app is given one user ID which is unique. User ID or process ID is same thing. Each installed app is given the process ID which is unique. As you see on your diagrams, this is a central based system. Here is your 3 virtual machines. They are considered 3 virtual machines. So it is written VM1, VM2, VM3. Then process ID 1, process ID 2, process ID 3. It is written on your screen. Then you have your APK1, APK2, and APK3. Now let's read it out. Permissions are set for every app. You have the permission. For example, if I install CRED app onto my phone, even today also, if I right now install the CRED app, after installation, it will ask, want to access your phone contacts. Allow. There is one option, allow this time, allow only, allow every time, or allow while using this app. There are 3 options. Whichever the button you will press, it will accordingly take your contacts from the phone to its own application. So what CRED do is, CRED ask for the permission to get the phone contacts. You allow, it will fetch the phone list, phone contact list from your phone to its database. Fine. So this is how it will done. So the permissions are there. So it is written permission, and downside it is written resource. If you can see the diagram, it is written permission X comma Y, Z comma A, X comma A. That means permission has been given. Permissions are requested by the apps, but the consent is to be given by the user. Permission is asked by the app, For example, I want to install for any app on my phone, it will ask for the permissions, but it is my consent, it is my wish to give the consent to access the contact or deny. Fine. So that means permissions are set and consent to access is given by the user. So each app is running in its own VM. Each app is given its own individual space to run. VM1 is given to APK1 to run. This is 2 is given to APK2 and 3 is given to APK3. So three of them are running in their different spaces. So that means they are given the separate environment and there is no interference amongst them. There is no interference amongst them. They are running in their own environment and in their own execution space. Then when you start interacting with the app, once you have installed, you start interacting with the app. As soon as you open the app, the process starts. When the users start interacting with the app, the process starts. The time you get bored from your app or you press the back button and the icon comes, the process is stopped. The process is stopped. So next is, it follows the principle of least authority. It follows the principle of least authority. Now, what is the principle of least authority? Principle of least authority. Suppose there is app A, there is app B. This is app A, this is app B. Fine. They want to share some data. They want to share some common data. Let it be C. Fine. So A and B will request the C to give us the access to access C. A and B will ask the C for the permission to access it. For the permission to access it. Now what C will do? C will give the minimum permission to A and B. C will give the minimum permission to A and B so that they can achieve their goal. Only that much data will be provided by the C, or that much access of the data will be provided by C so that the goal of A and B can be fulfilled. No more data. Suppose A is asking for the contacts. B is also asking for the contacts. So C will give only the contacts detail. It will not give the access to its messages or its to WhatsApp folder so that A and B can access them. Fine. So C will give the minimum authority to access the A and B. It will give so that its purpose should be fulfilled. So both of them, this principle of least authority is taken care while making the sharing of data, and second is while giving the permission. Now permission part is like that if some app is asking the permission, it will give the permission. It is up to the consent of the user. If user want to give the consent to access the app, then it is okay. If he does not want, then no app can access this app forcefully. Fine. Now while sharing of data, what happens? Suppose this is A and B. They want to access the database which is of C. Fine. So they are asking the permission of the C. Now what happens? So suppose its process ID is 1. Then B app will also be given virtual process ID 1 because they want to access the same resource C. Fine. This resource will get the, that means it will consider A and B as one resource, that is PID 1. Fine. And both of them, A and B, will sign the same document, will sign the same certificate. A and B will sign the same certificate. What does that certificate contains? The certificate contains that they will not misuse the data. That they will not misuse the data or misuse their rights. They will not misuse their data, or they are not supposed to misuse their rights or the permissions which are given to them. Fine. Next is the components. So Android components are the essential building blocks of app. Each component is different point through which the system can enter your app. There are 5 different app components. Each of them have this different purpose and has its own life cycle, and it defines how the component will be created and how it will be destroyed. So what are the 5 components of an app? So the 5 components of an app are: number one is activity, number two is intents and broadcast receiver, number three is service, number four is content providers, and number five is widgets and notifications. Now we will explain it one by one. Now what is your activity? The activity is the first building block of the Android application. So there are screens which are in front of you which you can see. So WhatsApp window is open where the chat is mentioned. That is also an activity. On the other side, there is one Facebook page that is also an activity. Any component which you can see or any activity which you can see on your mobile, that is this Zoom app in which you are looking at the whiteboard and PPT itself, this is also an activity. Fine. So this is activity. So activity is the first stepping stone in the building of user app. Each activity is implemented as a single class and that extends the activity based class. Your class will be display a user interface composed of views and respond to the events. For example, a text message application can contain one screen that shows the list of contacts to send the message, and a second screen to compose the message, and the other screen to review the old messages or settings. I show you one window. See, you have this email. This email, when you look at your primary box, there is one button which is mail, which is rounded with red circle. If you can see on your screens, this is the uh, mail icon. That means to compose the mail, then this activity will open. So this is your first activity, and you will move after pressing this compose button to the second activity. Fine, that is your compose. Fine. So that means there can be multiple activities in your application. Just like website contains web pages, your application or Android application or app contains activities. Fine. So activity is the any screen where user can interact with. Now what are views? Views are controls like text boxes, buttons, image box, image buttons, text views. Then you have check boxes. Then you have radio buttons. These are all views. These are all views. Now, what is the event which is to be performed on button click? Suppose I want to change the color of the background. That is on clicking of button, my background should change. This is what events. So activity can have the views on the design part and the functionality of these components on the Java side. So events will be made on the Java code. Just like you do the string programming in your Java, what you do, you make this control button on the front end, and what is the functionality to be added in the Java code. So this is how we do in the Android. You will put the views in XML part and events in the view part. So that means You want to link multiple activities? See, this is my activity which contains the message. Your OTP is this. Your OTP for transaction is suppose 65535. This is the OTP transaction which I have given. Now, when you click on this is one activity which you are screen, activity A, when it is showing you. Now, when you open this message, you just unlock your screen and open this message, another screen will open where the message will be there. So here it will be written messages and one box will be there and so many messages would be there in your screen. Now, when you click on the first message, that is this, then it will be enlarged and open like this and it is written your OTP for transaction is 65535. Fine. So how many activities you have traveled in order to open this OTP message? Two activities. First activity is the main screen. Second activity is a message and third is this box. So this is how the activities are there. So that means there are multiple activities in the app and where one is the parent activity. First activity is the parent activity and other activities are child activities. Fine. So next component is intent. Android uses a special class called intent to move from one screen to another. They're the way of the communication medium. They send messages to one another like you send your messages to the pin. So it is a messaging object and it can be used to query an action from another app component or it can be used to instantiate new activity or get result from other activity. Now the service can be started in bypassing an intent to perform a single operation. I will explain this service part later on, but intent means moving from one activity to another using some messages. So as you can see, the app activity represents a single screen with the user interface. So with the help of intent, when you have pressed the compose button, it has moved from this activity to this activity where your this compose box is coming. After you press back button, first activity is resumed. Fine. So this is how you have traveled from one activity to another with the help of intents. So next is broadcast receiver. This is very, very important. I'll show you one screen on this behalf. Just wait. I will be making diagram of this. We will take one example. See what happens. These messages are generated with the help of broadcast receiver. Battery full, new message arrived, or battery critically low. Fine. So what happens when battery is drained? Let us take the example when battery is critically low. So when battery is drained, or some battery is full, or some message is received, there is a disturbance inside the Linux kernel. There is a disturbance inside the Linux kernel. Now, Linux kernel operating system starts sending the message, starts broadcasting the messages to all the apps. Start broadcasting the message to all the apps in the phone. Fine. Now, it will ask, is there anyone to handle this information that battery is going to be critically low? So, the program called broadcast receiver listens to this announcement which is generated by OS. Broadcast receiver is a program which listens to the announcement which was made by operating system. Now what does it do? The broadcast receiver receives this message, and with the help of the intents, it generates the message called battery low. It generates the message called battery low. This is how the broadcast receiver works. It is written in front of you, a component that responds to system-wide announcements, broadcast announcement. Now, who will make this broadcast announcement? OS. OS of mobile phone will make the announcement. If the battery is drained, it has to intimate that battery is low. Fine. It wants to intimate that battery is low. So broadcast can be both from the system and your app. Any app can give the broadcast, or it can be a system generated. So battery low, new email notification, new message has arrived. These broadcast messages are, which appear on your screen, are generated by the broadcast receiver. So there is one more example. Suppose call is incoming. Either you will accept the call or you will decline the call. Now there is a call recorder which automatically starts when you accept the call. So call is incoming, OS gets disturbed, OS starts broadcasting the message. Is there any app which will handle this incoming call? So call recorder will say yes. So that means call recorder has a broadcast program called broadcast receiver, which will hear to this request which is made by OS, incoming request by OS using the intent. This message has gone to this, and this is with the help of intent. This is again with the help of intent. Now, broadcast receiver will ask the call recording service to store this data into the database using the intent. So without disturbing any call which is coming to your mobile, the broadcast receiver instructs the service to store your call into the database, and this is with the help of broadcast receiver. When call is coming through intents, OS starts broadcasting the message to all the apps, that whether any app which will handle this incoming call. Then again, the broadcast receiver of call recorder says that yes, I am here, which will receive the call and passes it to the service through the intents that you have to record this call into the mobile database. So as soon as you put your call down, you will get the recording of that call into your phone. So this is with the help of broadcast receiver. Fine. So next component is the service. Service is nothing but the task which executes in the background and user cannot interact with the service. For example, you are playing game. Your emails are downloaded in the background. That means when you move to the email, you'll find new emails. You have new WhatsApp messages. where the counter keeps on increasing, 708 messages, 101 messages, 3 new messages. So it will keep on coming. That means these are the tasks which keeps on executing in the background while you are playing game in the foreground. So component is nothing but a service or a component which runs. Service is nothing but a component which runs in the background to perform the long running operation or to perform the work for remote processes. It can be started by an activity. For example, if you are playing the songs in the background, then you will start it by the activity and song will keep on playing while you are playing in the game. User may or may not interact with the service directly. So this is a screenshot of the phone, Samsung phone, where you are seeing how many apps are downloaded, how many are running. See, Facebook notifications come whenever you open your Facebook, you find new person's profile or new person's post. So Facebook is the app which always keep on running in the background. Similarly, when you are sleeping or when you are seeing any movie on the Netflix on your mobiles, then WhatsApp keeps on bringing the new messages if it is there. Hike process is there, messenger. If some processes are need to be, some apps are required to be updated, they are updated in the background on the regular basis. So this is done with the help of service only. So next is the content provider. Content provider is nothing but when you use the SQLite database in the backend and you want to query it to get the data, to get the result of the query, then content provider will ask the SQL. For example, you have number of downloaded files in your mobile. You want to locate some Excel file or you want to open some account, your assignments from your mobile, that you will look in the download manager and you will retrieve it using the search box. So that is done with the help of content provider. So manages a share set of app data. It can store the data in the file system, a SQLite database or web or any persistent storage location. So even you can query it from the web also. You can get the this thing in your content given by content provider. So widget, I told you that it is the favorite programs or favorite apps which you want to see in your screen, like your watch, clock, your calendar, your weather app or your music app. So these are all the widgets. And notification, as the name says, it keeps the user aware of the events which are going on. So he is informed, like any news which is coming on the news channel, any news which is flashing on the news channel right now. And Facebook notifications are there. If somebody, some friend of you has sent the new friend request, then the notification will come to you. WhatsApp, new messages are coming on the WhatsApp, then the notification will come to you. So anything, any new message which is coming in and around your environment is given to you by the notification itself. Fine. So I want to give a little bit detail on this part of content provider. I'll show you what is content provider. Let me open the mobile phone. See, this is one app in my mobile or some baking app. So if I want to open this making a flour, for the cake. So I am just uh, clicking it and it will start playing in the your video. It will start playing the video. So this is your content provider, which starts playing a video in the video box or video window. So this is like what is a content provider all about. So it will start playing the video and it will give you the video into the video box or into the video window. Fine. Or we can have the, see, this is the number list. If I press this number SM, fine, I'll get its detail, complete detail. Sorry. See, I'm getting its complete detail. This is what content provider provides me. This is how content provider fetches the data from the database and displays it for me. So this is how it, see, if you can see, WhatsApp number is there, message is there, voice call is there, or video call is there. So thank you so much for the patient listening, and thank you very much for this session. If you have any queries or doubts, you can ask me.